This is your question. Now, how will we attempt this question? Clearly, this is clearly, if you see, the highest power of x here is 3, right? Which means this is a cubic. Okay, so let's start with by saying let fx is equal to 2x cube plus 3x square minus 9x minus 10. Recall the definition of 0 of a polynomial. If you remember 0 of a polynomial, I told you 0 of a polynomial is that value of x or that value of variable in the polynomial for which the polynomial becomes 0 or vanishes. Okay. So now what we do is our first attempt here is, if nothing is given, we look for a 0. And how do we look? We look randomly by trial and error method. Okay. Now what do you mean by trial and error method? Suppose, see, this expression is valid for all real values of x, right? So what you try to do here is you try to take values of x like 1, minus 1, 2, minus 2, 3, minus 3, put it here, put x is equal to 1 here and check whether this becomes 0. Next, put x is equal to minus 1, check whether this becomes 0. Put x is equal to 2, check whether this becomes 0. Put x is equal to minus 2, check whether this becomes 0, and you repeat, you continue this. Okay. You can put x is equal to half and minus half also. Okay. You can put x is equal to 1/3 and minus 1/3 also. Okay. And so on. You put these values and check whether the polynomial vanishes. Okay. This is, you're going to do this in your rough. Okay. For each value of x, you will check whether it vanishes. Now, once you know that it vanishes, suppose, for example, here, it will be seen that fx vanishes, or let's say fx is equal to 0 at x is equal to 1, at x is equal to minus 1. Fx is equal to 0 at x is equal to minus 1. I checked for all the values. I checked with 1, I checked with 2, I checked with minus 2. All the values I did not get 0. But for here, for minus 1, I got 0. Okay, so fx is equal to 0 at x is equal to minus 1. That means what can I say? X is equal to minus 1 is a 0 of the polynomial. Is a 0 of the polynomial fx. That means if x is equal to minus 1 is a 0, that means by factor theorem, what can I say? X plus 1 is a factor of fx. This I can say by factor theorem. So I've got one factor, which is x plus 1. And how do I get the other factors? We divide. So you divide x plus 1. The divisor here is x plus 1 and the dividend here is fx. Fx here is 2x cube plus 3x square minus 9x minus 10. You divide. So you need a 2x square, and 2x square into x plus 1 will give you 2x cube plus 2x square. So this is 2x cube plus 2x square. Subtract. This cancels. Simply get x square and you bring down minus 9x. So now you have x, now you have an x here and you have x square here. So you need to multiply x plus 1 by x to get x square plus x. So you get x square plus x. Subtract, cancels. And now you have a minus 10x, minus 10. So here you have x and here you have minus 10x. That means you need to multiply this by minus 10. X plus 1 you need to multiply by minus 10. You get minus 10x minus 10. And you write whatever you have multiplied by. In the second step, we had multiplied this by x plus x. So you write a plus x. Here I had multiplied by minus 10. So you write a minus 10. And subtract. Get 0. So what is the quotient that you are getting here? Remainder is 0. So therefore, what can you write? You can write 2x cube plus 3x square minus 9x minus 10 is the product of x plus 1 and the quotient 2x square plus x minus 10. Okay. Now you can split the second one, that is 2x squared plus x minus 10, into two factors also by middle term. What are the factors? Plus 5 and minus 4. So what are the factors? 2x plus 5, x minus 2, and x plus 1. So you're getting three linear factors because this was a cubic polynomial. Any question?
No, sir.
Okay, then I conclude this chapter here. Okay.
Yes, sir.